Your calculator says error. Your textbook says the limit exists. Both are right. Here is why. Look at this function. F of x equals x squared minus 4 divided bx minus 2. Plug in x equals 2 and you get 0 over 0 undefined. But that is the wrong question. The right question is, what value does the function approach as x gets close to 2? That is exactly what a limit answers. A limit describes the value a function approaches as the input gets close to a specific point. The notation is the limit. As x approach, EO x equals LX equals L. X never has to equal A. It only has to get close. Write that down. It clears up most of the confusion about limits. Now let us solve the opening problem. We want the limit as x approaches to of x squared minus 4 divided by x minus 2. Step 1, direct substitution. Plug in x equals 2. We get 0 over 0. That is an indeterminate form. It does not mean the limit doesn't exist. It means we need a different technique. Step 2, factor the numerator. X squared minus 4 is a difference of squares. It factors as x plus 2 times x minus 2. Step 3, cancel. The x minus 2 in the numerator and denominator cancel, leaving x plus 2. We can cancel because x is only approaching 2, never equaling it, so we are never dividing 0 by 0. Step 4, substitute. X plus 2 at x equals 2 equals 4. Box it, want to see it visually. Watch x approach 2 from both sides. From the left, 1.9 gives 3.9. 1.99 gives 3.99, closing in on 4. From the right, 2.1 gives 4.1. 2.01 gives 4.01, also closing in on 4. Both sides agree. The limit is 4. Now what if both sides do not agree? That is a one-sided limit situation, and it is a common AP exam topic. The rule: two-sided limit exists only if the left-hand limit and the right-hand limit are equal. If they differ, the limit does not exist. Write DNE. Example: g of x equals x plus 1 when x is less than 2, and 1x is greater than or equal to 2. From the left, the limit is 3. From the right, it is 5. 3 does not equal 5, DNE. Here are the 3 techniques you must know. 1. Direct substitution. If the function is defined at the point, just plug in the limit as x approaches 3 of x squared plus 1 equals 10. Done. 2. Factoring and canceling. Use this when you get 0 over 0 factor. Cancel the common term, then substitute. That is what we did. 3. Rationalization. Use this when a square root causes the indeterminate form. Multiply numerator and denominator by the conjugato, clear the radical, and cancel and substitute. One more topic: limits at infinity. The limit as x approaches infinity of 3x squared plus 5 divided by x squared minus 1. Divide every term by x squared, the highest power present. You get 3 plus 5 over x squared divided by 1 minus 1 over x squared as x goes to infinity. Both fraction terms go to 0. Result: 3 over 1 equals 3. The limit is 3. That means the graph has a horizontal asymptote, 80 equals 3. Shortcut: when the degrees are equal, the limit is just the ratio of the leading coefficients, 3 to 1, which is 3. Pause the video and try this one yourself. The limit as x approaches negative 3 of x squared plus x minus 6 divided by x plus 3, direct substitution gives 0 over 0. Factor the numerator. X squared plus x minus 6 equals x plus 3 times x minus 2. Cancel x plus 3. Substitute x equals negative 3 into x minus 2. Negative 3 minus 2 equals negative 5. The limit is negative 5. Quick summary. A limit describes what a function approaches near a point. X never has to equal that point. For a two-sided limit to exist, both one-sided limits must match. 0 over 0 means factor and cancel. For limits at infinity, divide by the highest power of x. That is limits. Everything in calculus, derivatives, integrals, continuity builds on this. Follow for more AP Calculus step by step.